Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review percentages. Percent just means per 100. So if I have a shape like this that's been divided into 100 little squares, 74 are shaded. So 74 out of 100 are shaded, 74 per 100 are shaded. So we can write that like this, 74%. That's what I mean when I say percentages are just fractions with denominator 100. 74% just means 74 hundredths or 74 over 100 in exactly the same way. 31% is the same as 31 over 100. The reason percentages are important, as we will see, they allow easy comparisons. It's easy to compare fractions when the denominators are equal. So we'll look at using percentages for comparisons a bit later, but first we're going to look at converting from fractions or decimals to percentages and vice versa. So you simply follow this diagram at the top. If you've got a fraction or a decimal, times 100 to make it a percentage. And if you start with a percentage, you divide by 100 to get a fraction or decimal. So let's convert all of these blue ones here to a percentage. All I do is times by 100. So if I times 0.4 by 100, I get 40. So 0.4 and 40% are the same number. If I want to convert this to a percent, I times by 100. 0.02 times 100 gives me 2. 0.02 and 2% are the same. So for 7 over 25, I just put that in my calculator, times by 100, and that is 28%. So if you got 7 out of 25 in a maths test, not that you would get 28%. So what about this fraction here, which is improper? Well, there's no different rule for improper fractions. If I want to convert to a percent, I just times by 100, and I get here 102%. You can have percentages over 100. All right, let's take each of these percentages and convert to a fraction or decimal. So all I do is divide 90 by 100 on my calculator. So as a fraction, it's 9 over 10, and as a decimal, it's 0.9. If you want to convert between fractions and decimals, you use the S to D button on your calculator. So something very similar for 72%. It would be 72 over 100, but that simplifies to 18 over 25. And that would be 0.72 as a decimal. So what about 7.5%? Well, I can put that on my calculator. 7.5 over 100 simplifies to 3 over 40, and as a decimal, it's 0.075. So what about 0.5%? Well, just because it isn't a whole number doesn't mean we're going to do it any differently. So 0.5 over 100 simplifies to 1 over 200. And as a decimal, if we divide that by 100, we get 0.005. So what about 120%? Now we've got a percent more than 100, but that's okay. We just go 120 divided by 100, which simplifies to 6 over 5. That's as a fraction, and 1.2 as a decimal. So numbers that are more than 1 correspond to percentages that are more than 100. All right, let's now look at using this to solve some problems. So this is where percentages can be very useful. This is why we have them. They're great for comparing. So let's say the Broncos have won 6 out of 16 matches. So I can write it like this. Arsenal, on the other hand, have won 9 out of 25, which I can write like this. Now, it's very hard to compare these fractions because they have different denominators and different numerators. But what I'm going to do by converting to percentages, I'm going to convert them to fractions whose denominator is 100. See, when I'm converting to a percent, I'm essentially finding what number goes in each of these boxes. So we know to convert from a fraction to a percent, you times by 100. So 6 over 16 times 100 actually gives you 37.5. 9 over 25 times 100 gives you 36. See, the Broncos, they've won 37.5% of their matches. Arsenal have only won 36%. So it's very clear now that we've converted to percentages, Broncos are going slightly better, although neither team is doing particularly well. It's so easy to compare fractions when their denominators are the same. And we use 100 because, base 10 system, it's a common number. All right, let's try this question here. Last year I was 150 centimeters tall. This year I'm 162 centimeters tall. By what percentage has my height increased? So my height has increased by 12 centimeters out of the 150 I started. If I want to convert that to a percent, I just times by 100. So putting that on my calculator, I get 8. The answer is 8%. My height has increased 8%. That means for every 100 centimeters tall I was, my height has increased by 8 centimeters. All right, now we're going to look at sort of the opposite, when we already know the percent, but we want to calculate a quantity. So when we're finding a percent of a quantity, we just follow 2 easy steps. Write the percent as a fraction or a decimal and then multiply. So let's try this question. Class of 32 students, 62.5% of them are boys. How many students are boys? So what we're being asked to find here is 62.5% of 32. Now we know that 62.5% is the same as 62.5 over 100. That's what percents are. We know that of means times. So all we do is convert percent to a fraction and then multiply. So if we put that on our calculator, we get 20. So there are 20 boys in the class because 20 out of 32 is 62.5%. All right, let's try this question. A video game normally costs $80, discounted by 30%. What will the game now cost? So if we want to find 30% of 80, we just convert 30% to a fraction or a decimal. This time I'll use a decimal, but it doesn't matter. And then we times by the quantity. So here 0.3 times 80 is 24. What that means is $24 is the amount by which this game will be discounted. So the amount it will now cost is 80 minus 24, which is equal to $56. So in both of these cases, we're calculating a quantity. We're not calculating the percent because we already knew the percent. So there's actually a quicker way I could have done this. If you discount the cost of something by 30%, you're only paying 70% of the original price. So 70% of 80, I can just convert percent to a decimal and times, and I get the same answer of 56. So either way you want to do it is fine. All right, let's look at a slightly harder question now. So sometimes you will have to find the original amount after a percentage has been applied to it. And when you're doing that, we're going to see that we always divide. So let's look at this question. At a school, 40% of students have blue eyes. 132 students have blue eyes. How many students attend the school? So we're trying to find the original amount. See, what's happened is we took 40% of the total number of students, which we don't know, and we found that that was equal to 132. So we need to find what number goes in the box. Well, we know 40% is the same as 40 over 100, which simplifies to 2 over 5. We know that of means times. If we want to find what number goes in this box, we need to undo timesing by 40 over 100 by dividing by 40 over 100. So the number that goes in the box will be 132 divided by 40 over 100. So when we're finding the original amount, rather than multiplying, we divide. So you can put that straight in your calculator and you get 330. So the original number is 330. 330 students are at the school because when you take 40% of 330, you get 132. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.